Hi, my name is Michael Thomas. I'm the Chief Data Scientist at Ketchbrook Analytics. We are a consulting firm that specializes in R, Python, and everything open source. And we have expertise at the intersection of data science and risk management. And we are so thrilled that the R Consortium put on this conference and invited us to speak here. And I'm really excited to talk to you today about creating fully reproducible model validation reports using tools like Docker, R, Quarto, renv, and targets. It's no secret that in the last few years there has been a bit of a reproducibility crisis in science, and I wanted to take a step back and think about why this might be the case. Tools like R and Python gave rise to an entirely new profession called data scientist and allowed us as model validators to take advantage of open source software as opposed to using legacy tooling like SAS, MATLAB, Stata, or Excel. And R and Python enabled folks who primarily had a background in the sciences to write software. The only problem was I'm not sure if these people even realized that writing R or Python code means that you are developing software. And when you are developing software, there is a whole suite of best practices that are important to ensuring your software is robust, that it's doing what you expect it to be doing, and it's usable by others. And what we had was a disconnect between science and software engineering, and that still exists today. And one of the main goals of this presentation is to get you thinking, if you're not already, about how you can bring strong software development best practices into your day-to-day work to make sure that whatever it is you're building, an analysis, a white paper, a statistical model, make sure that it's reproducible. Because A, making something reproducible inherently makes it better. And B, if your work is not reproducible, why should anyone trust your results? In some of my previous roles, I have been on the other side of this. I've received model validation reports, Word documents or PDFs from third parties with no lineage of how they did their work. I just had to trust that their analysis was right. And as a consulting firm, it's extremely important to me that our work is reproducible by our clients. If not, I would expect that they'll lose trust in us. I do have good news. This is a mostly solved problem, but it involves some tooling that you may not be familiar with, tooling that wasn't really synonymous with data science until the last 3 or 4 years. And this is what that stack looks like. It's Docker for scripting your environment down to the operating system and versions of all of the software dependencies that you're using for your project. R as the computational engine. Quarto for authoring scientific documents. renv for managing the versions of the R packages that you're using in your project. And targets for turning your analysis into a fast and efficient directed acyclic graph DAG style pipeline. And if you wanted to hand off your work to someone else, you could ask them to maybe first install this version of R, install RStudio probably, tell them to install these specific R packages and hopefully tell them specific versions, tell them how to install those specific versions. If it's a report, tell them to install Quarto, tell them that they'll need to run these particular scripts in some particular order, and give them more and more instructions for things that the end user will need to download, install, or run manually. Nowadays, this is what we say to clients. We tell them you'll need to have one software dependency installed. That's Docker. And then maybe run 1 or 2 commands. That's it. And you will be able to fully reproduce any of the work that we provide you with, including our model validation reports. And I want to show you what this looks like in practice now. I want to get into an example, and I've put together a demo GitHub repository for those that are following along with the link at the bottom of all of the slides that we have there. We'll take you to the slide presentation, and then you can get to the last slide in the presentation that has this GitHub repository link in it. So I'll give everyone a minute to do that. So now that we're at the GitHub repository, I am going to clone this locally to my computer. Obviously, you could do that through the command line if you'd like to. There's a lot of GUI tools out there as well. My favorite is GitHub Desktop. So I am going to clone this repository locally with GitHub Desktop. And I am just going to stick it right on my desktop, actually. And let's take a look at the files that are in there. VS Code is my IDE of choice. Obviously, you can use Positron, whatever you prefer. And I thought that this would be the best way to walk through the files in the repository rather than on GitHub, is that we could actually talk about sort of the structure of the repository and then be able to look at the files as we explore them. So maybe I'll go upside down, if you will. I'll start from the bottom. So report.qmd is our main Quarto script that governs the whole report. It's kind of the parent Quarto script, if you will. So I can open that up quick and show you what that looks like. We have these markdown header sections for all of the different major sections of the report. We have the report's title and subtitle. And then underneath all of these markdown sections, we have these small include shortcodes, they're called, which allow us to essentially stick in child Quarto documents. And all of those individual child Quarto documents are specified in a folder called QMD. So if you take a look at the scripts that are in here, they'll look a lot like the paths that you're going to see in all of these shortcodes. I have a page break between each section just because I like to have a kind of logical separation between the major sections of my report. And one of the reasons that we try to modularize our code this way is I'm just a big fan of modularization of code in general. And second, it allows our team to work a little bit more asynchronously. So I can assign section 2 of conceptual soundness portion of our validation to one teammate and the model reperformance section of our validation to a second teammate, and not necessarily have to worry that they are going to be editing the same script at the same time. And if you want to take a look at what these individual, what we call child QMD documents look like, we can pop one of those open, and you'll see that most of the headers in here start with these 3 hash symbols, which are kind of the subheader underneath the major headers that had 2 in each section of our report. So these are the subsections underneath each major section. We have an executive summary that has a few different subsections, including the model's history and purpose, some overall conclusions that we had, our recommendations for the client, some notes on reproducibility that we include in all of our model validation reports. No surprise there. And you can scroll through and take a look at any of these different sections, or these child Quarto documents, if you will. And we'll talk about how these all stitch together and the different tooling that they leverage to create our final model validation report. The next file in here that I do want to jump to, I think, will be our _Quarto.yaml file. And this is what's called a project Quarto file, or a Quarto project file, that allows us to specify some Quarto parameters that we do not have to pass to this section of any of our QMD documents. So we can specify essentially default parameters for any Quarto document that exists in this repository, any parent Quarto document like report.qmd. So we can hop into there, and you can see that we have a couple different parameters here, and I'm not going to go through every single one. I'm going to highlight a couple. When this document is finally rendered, the output that it's going to produce is going to end up in a new folder, if it doesn't already exist, called _output. So that's where we'll see our final rendered PDF report. You'll note that the format that we are rendering to is typed. And for those familiar with our Markdown and LaTeX, this might be similar but new to you. Typed is a much more modern approach to scientific publishing in PDF documents programmatically. It's a lot faster than LaTeX. One of the nice features when it comes to Quarto is that types is built into Quarto. So if you have downloaded and installed Quarto on your machine or in your environment, types nowadays will be installed as well in that project. So there's nothing additional that you'll have to go out and get. And I can also specify some custom parameters here that will apply to my project that actually get passed to my Quarto files, my QMD files, through these typed template files. And if you're someone who's ever messed around with, kind of difficult customized LaTeX type things, this might be familiar to you in terms of trying to brand your report and make a repeatable process. A couple more arguments. We want to include a table of contents, a list of figures, a list of tables. We have some header logo and background images that you'll see in the final document. Our bibliography is going to be in this references.bib file. And for any Mermaid.js diagrams that we create, and for those that aren't familiar, Mermaid is a JavaScript tool for creating workflow diagrams that is fantastic and plays nicely with Quarto. We're just setting the theme to those diagrams, which controls the styling to the default theme. And I'll jump back up to this bibliography file. A really nice feature is that you can have a .bib file, which is a bibtex citation type file that you can include all of your references and citations that you want to include in your model validation report in this file. You pass it through quarto.yaml in this parameter here that we mentioned. And the only other thing that you need to do is in your parent document at the very end of it, assuming you want your references to go at the end of your document, you use this exact sort of code chunk right here. These three colons followed by this code right here, refs, and then one more at the end, and that will automatically nicely format and pull in all of the different citations that you have specified in this file, which is great. The next file that I want to talk about is going to be the R folder. I want to talk about these scripts in here. So these are where we write our custom logic, and when you are working with targets, which I'll go into in a minute, everything really needs to become a function. We get away from sort of non-functionalized code, and we actually have to sort of create a function for everything that we want to do for the most part within these types of projects. So I have a function here for reading in the client's data for model training purposes, which they give to us in a CSV. I use the reader package to specify the particular columns, column types that I'm looking for. We have one here for model reperformance, which has some functions that programmatically fit a logistic regression model for us, which is what the client used. So we do that, reperform the model fitting process ourselves based upon their documentation. And then we compare that to the model parameters that they gave us in their documentation, which I can hard code here and pull in as an object into my targets pipeline. We have a couple more scripts in here, and this is kind of structured like an R package, if you will. We have this R directory, and then we have all of our custom functions with nice Roxygen documentation in these .r files underneath this R directory. We have another one here for sensitivity analysis, and then another one here for creating tables in our report specifically. So I'll go back to the top here and talk about this underscore targets directory. This is something that targets creates automatically. Honestly, if this wasn't even here, it would make no difference in your ability to reproduce the report based upon this GitHub repository that I'm showing you today. So I won't talk too much about this, but we don't check the actual targets objects into version control, and targets does a pretty good job at managing that for us. Again, this is all sort of created programmatically when we use targets, but it does contain sort of the metadata for that DAG pipeline. Again, not necessarily important to know. If this wasn't here, it wouldn't change anything. This .dev container folder contains essentially utilities that allow us to leverage Docker as our development environment. So we can develop in a Docker container as well and use all of that environment as code, scripting that we created to essentially ensure that our development work in our development environment is going to match the environment that the client will leverage to reproduce our model validation report. This assets folder contains some of these custom types files here that allow us to sort of pass some of these variables that we define in quarto.yaml to types to use in the project. Most of this pertains to the cover page. So we have two files in there. I'm not going to go too far into depth there, but it's fairly easy to pick up. I think you'd be surprised if you took a look at the types documentation. They've done a really good job, and obviously you can leverage this repository as well, or reach out to me if you have any questions about type styling, perhaps in particular as it compares to LaTeX styling. The next thing I'll talk about is the renv folder. And those familiar with renv know that it does a pretty good job at managing for you what you should and should not check into version control. So cloning this from GitHub is not going to give us actually all of the R packages sort of already installed here in our environment for us. It's just going to give us some configuration settings for renv, and the actual sort of lock file that governs the exact versions of each package that we want to install is down here in this renv.lock file. And I recommend you check out the renv project if you haven't already for more detail on that. It's pretty awesome. And the other thing that I want to go into, I think two more probably, I'll go into this _targets.r file. And this is a file that gets created when you run in your console, in your R terminal, you use _targets from the targets package. And this is where we define our pipeline. So we load a couple different packages and we make sure that we have all of our custom R functions in this R directory available for us in the rest of this script. That's what tar source does for us. And then we create an R list with all of these different targets, if you will. So this one is a target that specifies in our DAG pipeline what is the CSV file that we're going to want to use, where does it live, and this is really just going to return a path for us to leverage in downstream versions of in downstream targets, if you will. So you'll see this next target here, we're naming credit data. That's going to be the name of this next target. It's going to leverage this read credit data function that we have created in our dataprep.r script, which calls for a parameter and the file argument. And we can actually pass it this previously created target name. Doesn't need to be quoted or anything like that. So we can essentially create a target here and name it something that we can use downstream in this pipeline. So this is actually not very long of a targets pipeline, if you will. I think we have, maybe 6 or 8 targets, something like that. When you are doing, a really large model validation project, which sometimes our projects get into, 50 or 100 pages of analysis work at a minimum, this targets file can become pretty long. So I just want to let you know that, only seeing 6 to 8 here is fairly unusual for a larger scale project, but hopefully this gives you the idea of what is going on. And this next target here is where we are bringing in the model parameters from their documentation that we hard coded. This is where we are actually fitting and reperforming their logistic regression model using our fit GLM loss model function that we specified over here in model reperformance, and passing it that credit data target, which is a data frame that we created up here. And a couple more targets here that create a GT table, one that creates some ggplot objects, and then in our final target here, which is actually dependent on this additional package called Tarcha types, which is a sister project or cousin project to the targets, is where we are rendering our Quarto report, essentially underneath the hood running Quarto render. And I think the very last file I want to talk about is the Docker file. Here it is. So this is the file where we essentially script our entire environment, where we set all of these software dependencies that we want to be installed. And again, this isn't a markdown set of instructions or a Word document set of instructions that tells somebody to go out and download and install these pieces of software. This is software that creates your environment for you. This is scripting your environment. So I'm going to walk through this at a fairly high level. We can use arguments that can be passed to other areas of our Docker file. So right here I am essentially creating a variable called rversion, and I am using that to start by installing the R4.5.2 software in my environment. Then I'm also installing or defining rather the versions of Quarto and renv, the renv package that I want to install a little bit later on. I need to install Chrome here, and this is just one of those things that you could have gotten off Stack Overflow in the past. Now we can get out of ChatGPT. This is a fairly common thing in software development that you will need to install Chrome for web development, all sorts of types of things. When we are using Mermaid.js and rendering to PDF, not HTML, we essentially need Chrome in the background to help us take screenshots of these mermaid diagrams and stick them in our types to PDF files. Next thing we're doing is installing Quarto, and we're leveraging that Quarto version argument that we specified up here. So we want Quarto version 1.8.27, and this is right from the Quarto documentation on the Quarto website that'll tell you how to install that. We're going to install the pack package first here, and that will enable us to install the version of renv that we want to have installed. I'm doing a special little trick here, and if you dive deep into the pack or renv documentation, you can find that these two things actually have the capability to play together, even though on the outset it might seem like they are two totally different projects that sort of try to accomplish the same thing, package management in R. But they actually play really well together because renv allows you to create that lock file that specifies the exact versions of the R packages that you want. And pack not only installs those exact versions, but also installs any system dependencies that you necessarily need, or system packages out there that some R packages depend on. So we'll next install that particular version of renv, leveraging the pack package to do so. Then we're going to create a new working directory in our environment called project, and that's where we're going to copy everything from our local repository here into this containerized environment that we're creating. So we are taking all of these custom types files in the assets directory. We're going to need those to generate the report, but we don't need everything in here. We don't need the README in my repository in order to generate this Quarto model validation report. We don't need the license either. We just need the pieces of software and the scripts that are actually dependencies of creating this model validation report, and that's all of the child Quarto documents, that Quarto project file here, quarto.yaml, our targets pipeline specification, our custom R scripts that we have, our bibtech references file, the renv.lock file that will allow us to install the specific versions of each R package that we want, and the parent Quarto file for our model validation report called report.qmd. So we only really want to bring into this container just the files and directories that we need in order to produce the output that we're looking to get at the end of the day. And I have two more commands in here. The first one is going to be run renv restore, which is going to look at that lock file here, which is a very long file if you're not familiar with it, that has essentially a list of every single R package that your project needs and all of its subdependencies, the version that you used, and sort of where renv needs to go to be able to install that. And once all of your R packages are installed, your version of R is installed, Quarto is installed, Chrome is installed in your environment, you can essentially run the targets pipeline that we have created and defined using this targets tar make function. And remember, the last target in our pipeline creates the Quarto report that we have here, right here. And it is going to spit that report out into a new directory called _output, because that's what we defined here in our quarto.yaml project file. So let's pretend that I am one of Ketchbrook Analytics clients who just received my PDF model validation report from Ketchbrook, and Michael lets me know, hey, just so you know, we're also providing you with the repository, the code repository, and all of our work is fully reproducible. Just follow the steps in the README document in the repository. So now that I have this locally on my machine, I'll just take a look at the README. And let's walk through that and take a look at what that looks like together. So it looks like there are a couple steps. I can clone the repository to my machine. I've already done that. I need to add the model training data that I gave them into this same location underneath a new folder called data relative to the root of the repository. And the reason that I need to do that, again, remember I'm the client after having downloaded this or cloned this repository to my local machine, is that Michael and his team at Ketchbrook knew the best practice of never pushing data to a GitHub repository. Let's all say that together one more time. We don't push data to GitHub repositories. So I'm going to have to stick this CSV file that contains my model training data that I provided his team with, and they kept proprietary for us. I'm going to have to stick it in this data subfolder. Then I'll have to open a terminal and cd to the working directory. So make sure that I'm in the working directory of this repository on my local machine. I'm going to have to make sure that Docker is running, and then I'm going to have to run these two commands that he's provided me with. A Docker build command and a Docker run command. And it looks like he's done all of the hard work for me in this README, and there's some really nice explanations about what these two commands are actually doing. And it's telling me that once I run the second command, it's going to generate the model validation report in a new directory called _output, which I do not currently have at the moment. So now I need to take this model training CSV that I had provided his team with, and I'm going to put it in the repository at a subfolder he mentioned called data. And I will paste it in there. And that step of the README is complete, and I can move on to the next step. So after doing that, I have to open a terminal. Do that here and make sure that I am in the same directory as all of these files, and it mimics the GitHub repository that I cloned, and that is correct. I have my data folder here now with my synthetic credit data CSV model training data, and I can ensure that Docker is running in step 4 by typing a command like docker version, and I get an actual version number, not an error. So it looks like Docker is installed and running. Now I have to run the following two commands. The first one is going to build the Docker image, which is essentially going to install in this Docker image all of the software dependencies that I will need for my project that we specified in the Docker file. It'll do essentially everything except that last command in the Docker file that actually generates the report. So we can copy and paste this. And what comes after the T flag here is just essentially a name that I have given, a tag, if you will, to the Docker image that I'm going to build so that I can leverage it later when I go to actually run the container that leverages the Docker image. So I've called it Ketchbrook/risk-demo. And the little dot here at the end is sort of just a placeholder that says the Docker file that I want you to look for is located at the root of my repository, and it's called Docker file. If it's called something different or it's elsewhere, I'd have to specify that explicitly. But I can run this, and this is going to take a few minutes because it is installing a fair amount of software. It's going to install R, it's going to install Quarto, Chrome, all of our R package dependencies, and everything else that we specified in our Docker file. So I will run this here. And now that that is complete, I can, in the same terminal or in a new terminal like I'm in now, does not make a difference, run the second command in the README, which is going to actually produce the report, spin up that Docker container and produce the report. So you'll see that it is executing that command at the end of our Docker file that said run targets tar make, which then ran that targets tar make function, which executes our pipeline in _targets.r, which does all of the work to build all of the artifacts that we're going to use in our report and then create the report itself. And all of a sudden, we have popped up here a new directory called _output that is going to contain the stunning, but I may be biased, model validation report that we have authored with Quarto, types, R, renv, target, and Docker. And we have our mermaid.js diagram right there. We have Quarto callouts here. We have various hyperlinks. These are our citations right here in this format that will jump all the way down, that are hyperlinked to our bibliography. At the end of our report, we have some of those ggplots that we developed in the section on sensitivity analysis here that look wonderful. We have our table that compares our validated model parameters to the model parameters or coefficients that we received in the model documentation. See, we found a little discrepancy, an incorrect sign, so we're going to point that out, and that was all discovered programmatically, which is wonderful. And there you have it. And at the beginning of our report, we do have that nice table of contents, which, if you'll remember, was just a true-false flag over here in our quarto.yaml file. We didn't have to create this by hand. We just said, make a table of contents, TOC equals true, and it did all of the hard work for us. And the same goes with our list of figures and list of tables that we created. And the way that it found those was using labels in our report, in our Quarto chunks here, that started with this TBL prefix for tables, and for plots, they need to start with fig, and they will end up in your list of figures as opposed to list of tables. And when you actually take a look at some of these child Quarto documents, if you will, the way that we are able to call the Quarto artifacts or the targets objects that we create in our pipeline is in two ways. You can either do so through tar read function, which is essentially like just reading the object one time and printing out the results, if you will. Or conversely, you can leverage a function called tar load, which is what we're doing here, which actually brings this object into memory. And again, remember, credit data was the name of a target in our pipeline. We don't need to do any quoting or anything like that. This tar load function will go out and find that object that we created in our targets pipeline. It will load it into memory and into our environment, and now we actually can do things with that, like count the number of rows or figure out the number of rows that represent a default observation as opposed to a non-default observation, and pass that information that we've created here as objects in our R environment to, for those that are familiar with R Markdown, this should look very familiar, these inline code snippets, if you will. And there's lots more to see and talk about. I really recommend that you read the entire README if you are interested further in this topic. We have a lot more information in there for you all. And if you have any questions, please don't hesitate to reach out. Thank you so much.